very much for coming. Today's session is COS 202. This is about online analytics in the Azure cloud using HPC. And my name's Ward Britton. Thank you very much for coming to this session. I'll just start off with, this is my first tech ed. And this is my first time up here doing this. Normally I do a much different job, so please, I hope you enjoy what we've got to show today. Essentially, here's our agenda that we're going to be running through. Bit of an intro, who I am, why I'm up here speaking to you about this topic. I'm going to cover what's not in the presentation, just in case we thought that there was something else that would be covered today. Today, we're going to talk about a journey. I'm not an Azure expert, but I have a story. I have a journey that we went on, and I'm going to give you all the information that we discovered during that process. Part of that will be uncovering the mysteries of Monte Carlo simulation. We're going to talk about a proof of concept that we ran, what we found, what worked, what didn't. We're going to do a bit of myth busting. As we ran through this proof of concept, we had numbers of questions and naysayers and myths that popped up, and part of this proof of concept essentially was busting through those myths. And then we'll have a bit of a talk about what it would take to go the next step. If this was to be able to be productionised, what are some of the big rocks that need to be moved? Then we're going to have some Q&A at the end. Now, I'm going to leave time at the end, a good chunk of time at the end for question and answers. So I encourage you to please hold your questions. I really do value them and I want to cover them. But if we can do that at the end, that will be fantastic. Just want to let you know before we get into it too far, we've actually got a number of key members from the proof of concept team here in the audience. So after the Q&A, we can probably dive in and have a bit more discussion with those guys. So myself, Ward Britton, I don't work for Microsoft. I work for Westpac. I'm on the customer side of the equation. I am a principal architect at Westpac in the institutional bank area. I look after areas within the bank, including treasury, risk, and global infrastructure. My day job is not about building Azure solutions. My day job is essentially providing solutions to business problems, so understanding business problems and potentially applying technology to that, or process, all of the above, to come up with an outcome that is going to deliver business value. I've thrown a few highlights of my career at Westpac there up on the board. There's a fair bit of emphasis there you can see around grid computing and risk, and you'll see those themes getting drawn out in our discussions today. If you turned up today for a discussion about what is cloud or what is Azure, sorry, this is not the right seminar for you. As I mentioned, I'm not the Azure expert. There's a bunch of Microsoft guys here, and we have David McGee, who's going to do the demonstrations with us over here. David is what I would call an Azure expert. So if we've got any Azure questions for David, then I'm sure he'll be very happy to talk about them. We're not going to be talking about development on Azure. In fact, that's a key theme of this. No development, no cutting code. The message is really around out of the box. We're not going to be covering other applications as well. There is a specific application set that we work through in this proof of concept, which we are going to talk about in detail. These are really around this numerics application, which, if you haven't heard about that before, we're going to cover what that does and where that sits in this solution. We're going to talk about Excel, which everyone knows, HPC, and Azure. One other piece, I did mention risk before, risk management. We will do a quick 101 on risk management to give enough information so that we can get some context and understand the challenges here. We're not going to have a detailed discussion. That is beyond my capacity, but once again, there are some numerics guys here as well. So if you want to dive into that afterwards, I'm sure they'll be happy to have that conversation with you too. So, without further ado, we're going to take a journey. As I mentioned, this is a summary. This is a story. This is my story. This is the story that we've been on for a few months as we've gone through the journey of trying to solve a business problem with some pretty leading edge technology. The business problem started out very simply with the desktop locking up. You think, oh yeah, every day, right? The desktop locking up, how does that get solved? How does that get resolved? And going through that process led us down a path of applying different technology components to that to get to a solution which actually kind of worked pretty good for the proof of concept that we did. The initial technology stack of this problem was an application called Numerics, which runs on the desktop, and Excel 2010. So let me just talk about the business nature that is being run here, because the next thing we're going to talk about is risk management. So the journey started with one of our quantitative analysts, who, if you're unaware, are really, really, really smart guys, Rain Man smart, who said, look, Ward, I've got some issues here, this is not working, it's taking a long time, when it's running my desktop's locked up, I can't do anything, but I need to do it quicker and I need to do it reliably, because sometimes it even crashes. So had this conversation, looked into what was running on the desktop, found it to be Numerics and Excel 2010. Numerics being the risk pricing platform, the application that this business gentleman uses, the quantitative analyst, to go and do a number of complex risk calculations. Started out with, why are my Monte Carlo simulations taking so long? Why? Why is it taking so long, locking out my desktop and sometimes crashing? Very common type of question, yeah? Who in the audience hasn't had that question? No hands up, exactly. Right. It's the same as me. As I mentioned, I don't do a tech support role, but guess what? Being a technology employee, still there to answer questions and provide outcomes and solve problems as they come up, and they inevitably do. Looked at the problem, looked at the technology stack, looked at what was going on, why it crashed, when it crashed, how it locked up the desktop, what was going on under the covers. We then looked at something we're going to talk about a little bit more, HPC. We found, okay, there's an option. We spoke to the vendor, Numerics, and said, well, yes, we can do this HPC thing. We then had a discussion with Microsoft saying, well, if you've got HPC, then maybe there's something else we can do as well, this cloud bursting piece. So we looked through the data and said, oh, this is very interesting. There's this is maybe we've got a show here. And then essentially, what we're really going to be talking about today is then we kicked off a proof of concept to prove this single concept from end to end, that we could take the application and this particular job that is running on this guy's desktop, plug in these HPC and Azure, and make that run faster. In fact, make it run way faster. Make it run more reliably. And we're going to talk about some of how that actually comes about. This is a Monte Carlo simulation, or in fact, more technically, Brownian motion in operation. Each of these coloured lines represents a random walk over time. Somewhere buried in the middle is a standard deviation where our estimated price is going to be. So as you can see, if we run one of these paths, it's going to be nowhere near. If we run two, potentially, once again, nowhere near. But if we run many, eventually, we're going to have a convergence within our standard deviation to come up with the price that or the value that we estimated. So this method is very popular to price derivatives where there's no financial model available. It is run for each value. So all of these different paths that have been run have been to confirm one value, one price. What happens is that there's essentially a yield curve. So anyone do futures, options, derivatives, trading at home? No? Okay, so 101, yield curve. So over time, the time value of money. So we have 30 days, 90 days, 12 months, 3 years, 5 years. And for each of these time points, the value of that instrument, whether that be a stock, for example, needs to be calculated depending on the market movements. Because we don't know the market, we need to throw in a whole bunch of randomness to come up with that standard deviation of what we estimate the price to be. 101. That is what Monte Carlo simulation does. And what happens is for each of those points, 30, 60, 90 days, for example, on that yield curve, this is run. So it's run a lot of times. And the more simulations that are run, the better the price converges within that standard deviation. It's extremely CPU intensive, as you can imagine. There are many, many calculations going on just to really get one number. And it's run repeatedly. Numerics is the application that is being used in this situation. It plugs into Excel. It enables the quantitative analyst to utilise a mathematical library and a pricing library, all of which is provided by as part of the numerics package. Numerics is what was causing the desktop to crash as well, or lock up. So that was part of the solution that we were trying to run through. Numerics, Excel, and Windows. One of the key parts of this is that this is the application. This is the proof of concept that was solved, or that was worked on. Numerics, Excel. No other applications were looked at, just this one. As I mentioned, we kicked off a proof of concept. We had some strategic goals. Right in the middle, we were looking at cloud bursting. So, has anyone heard cloud bursting? Know about cloud bursting? Yep, a couple. Okay, great. So, it's a pretty cool term, I think. We're going to go through a little bit more about what that means, bursting from on-premise HPC. First, we're going to understand what HPC is. Anyone got HPC experience out there? Exposure? Cool. We're going to have a great coverage of that. We also wanted to have more simulations for better results. As I mentioned, the more of those paths that are run, the quicker, the more accurately we can converge the price within that standard deviation, the faster we get a better, more accurate outcome. So, more simulations for better results. We wanted to provide a cost-effective solution as well. Okay. Part of that cost effectiveness is the ad hoc nature of this activity. This activity is not run automatically each day, like a batch job, for example, to kick off at hour 1 and finish at hour 3. This is a job that is initiated, or an activity that is initiated by the user, the quantitative analyst in this case, on demand when it's needed to be run, which is maybe weekly, maybe fortnightly. But here's the thing, when it needs to run then and there and very quickly. So it's that ad hoc nature, which means that potentially building a whole bunch of hardware to support that, there's maybe a value proposition question there. To do this proof of concept, although initially sounded quite simple, yeah, we can fix this Excel problem, actually required a global team to do it, a multi-vendor global team. Numerics in Singapore and in New York, Microsoft, Redmond and Sydney, also New York, collaborating over time zones. Even within the bank, within Westpac, it wasn't just me. There is a significant team of others involved in that. Representatives from infrastructure, from engineering, of course security, who are a key player in this whole piece, and our design authorities as well. This team was formed from across the group, across the bank, like most of you. We've got IT teams that are very capable and responsive. So had the opportunity to really cherry pick some of the best guys out of this. So was very thankful for the team that was assembled to that. Also from numerics, we had some financial specialists, product specialists that understood not only the product but the nature of the problem very deeply. And from the Microsoft side, guys such as David, who knew HPC, knew Azure, and could help pull the whole thing together. We have Avanade involved as well. Avanade provided our project management capabilities that pulled all this global team together, also infrastructure specialists as well. So when it came to doing the build, Avanade got right in there involved in that. So as you can see, it's quite a large project team that was put together to solve this problem. It's not something that was done overnight in just by Ward Britain. To solve the problem, as we've mentioned, required bolting on additional layers onto the technology stack. The first one of these is Windows HPC server. If you haven't heard about that, and we're going to cover that, what it is, what it's made up of, what it does, where it sits. Additionally, we're also looking at Windows Azure. Now, we wanted to use, this POC involved using the VM role in Windows Azure, which is in beta. So we'll talk about that and how that worked as well, because part of using beta software is, right, sometimes it works and sometimes it doesn't. Right? So there's quite a few challenges around that. And also running Excel in Azure too. Putting these pieces together, stitching them together to get an outcome, to get that magic number popping out of the end of this process really was what this proof of concept is about. And that's really what we're going to be covering today and how to do that. I thought I'd make it a little bit of fun and cover the myth-busting element here. We need to bust some myths. When we kicked this off, there was a number of different questions being raised, and not just once or twice, but quite often. One of these is that if you're running an app on the desktop and it's going to lock the desktop up, the only way to fix it is to buy a bigger desktop. Right? It's Excel, that's the end of it. Well, that's one of the myths we're going to bust today, and we're going to bust that with HPC. The other one, which is dear to my heart, is that the banks can't use the public cloud because it's too insecure. Now, there is some truth to that, but we're going to have a look at that in much more detail. The third myth is connecting HPC to the cloud is quick, cheap, and easy. We're going to have a very good look at that because we found some quite interesting stuff come out of that piece. And finally, that all clouds are created equal. As we're on this journey, why don't you use this cloud? Why don't you use that cloud? Aren't they all the same? So want to address that as well as part of this, because there is some differences which really we need to be aware of that worked well in this POC. So, first one. Desktop apps like numerics, and I don't want to pick on numerics, but that's the app we used in the POC, so that's what it is. Can grind the desktop to a halt. So, as I mentioned, numerics Excel plugs into Excel 2010. It runs these Monte Carlo simulations. It uses a lot of CPU and a lot of RAM to do that. So, the biggest, baddest desktop that you can put there and run this on will eventually run out of puff. And while it's running, it could be basically unusable, seeing your little swirly hourglass, that kind of thing. So not really so good. And it can do that for hours at an end. Some of these simulations are looking at the value of, trying to work out the value of an instrument or a product out over 30 years. So there's a fair way in the future that needs to be simulated to get to that price outcome. So, I mentioned HPC. When we had a discussion with numerics about what could we do to fix this, I got on the blower to them and said, look, yeah, this is the problem. This is the outcome. What are the options from their perspective? And straight away I said, well, there's this HPC thing. You guys should have a look at it. Got off the phone from them, got on the phone to Microsoft, said, what's HPC? So we then had that discussion. HPC, to start at the beginning, is a bundle. It's a version of a Windows server. The OS has got one or two restrictions. Once again, if you want lots of details about HPC and product offerings and that, have a chat to the Microsoft guys. Just as a 101, the OS then has a pack built onto the top of it. This pack includes things like a job scheduler, integrated management tools, and also a SOA agent as well, so that you can actually set up services and call those directly. Bundling all those together, you get Windows HPC Server and R2. Now, we're going to talk about service packs because a key part of this is getting the right service pack to have these capabilities that we need, which is around workbooks. So, HPC stands for High Performance Computing. High Performance Computing, or HPC, is Microsoft's grid computing platform. Okay, so grid computing, yes? No? Yep, okay, so grid computing, right? 101. Taking a job, breaking it up into lots of smaller pieces, like an army of ants, if you will, throwing that job out to a number of different CPUs to crunch and process, and then bringing the results back to the originator. Grid Computing 101, right? HPC is that platform. HPC includes this framework where there's a head node. The head node is essentially the controller, right? The master controller. It the architecture then, it requires a compute group, which is a number, n, of compute nodes in the cluster, so one or more. These compute nodes, essentially the ones that are used to run the job, they do the hard work. The head node essentially dishes the work out to the compute group, and the compute nodes in that compute group then run the job and then return the results essentially back to the head and broker node, which then returns it back to the application. HPC, computing, grid computing, all of this is built essentially on-premise, okay? So grid computing has been popular for quite some time now. In fact, in universities, graphics houses, financial institutions as well, it's a way to solve huge compute-intensive operations without essentially buying a mainframe, if you will, but to do it on smaller commodity-based infrastructure and application platforms. HPC is what we looked at to plug into the back of Excel. We went and built an HPC Service Pack 2 platform, connected it up to numerics, took the workbook that was running on the desktop, offloaded that to HPC, to the compute grid, and ran it. The more compute nodes that are in your HPC grid, in your compute group, essentially the faster this thing is going to run. It's going to scale to a point. We're going to talk about that. HPC is not only the method by which you can distribute this workload out to the compute group, but it's a series of tools as well to manage the workloads, to be able to assign jobs to certain compute nodes within the group, to be able to re-image the compute group, if you like, or if you need to. For example, to run Excel on one of these compute nodes, you need Excel installed, right? If you wanted to run another application, you would need that other application installed in there. So therefore, you would potentially either set it up as a SOA service or re-image, bare metal re-image that compute node. HPC has got the tools to do all of that, which was quite handy. It allowed us to manage and monitor the process that was going on quite well. Architecturally, quite high level. This is how it looks, where you've got the quantitative analyst sitting at the Windows desktop, running Excel, running numerics. That workbook is then offloaded through to the head node, which will then pretty much break that up into pieces and dish it out to the compute grid. Now, these compute nodes are essentially all sitting there with their hand up saying, pick me, pick me, pick me, I'm free. When they're busy, their hand goes down and they're crunching a job. When they finish the job, hand goes back up again, pick me, pick me. And that's essentially how the workload is handled across the compute grid. Who wants to see a bit of HPC? At work, yeah? Well, that's cool. So you've been very patient. We've got a demo to show you. So I'm going to throw over to David right now, who's going to give us a bit of a run through of the HPC toolset. And away you go, David. Thank you.
Okay. Flip across.
Yeah, done.
Already there? Nice, thank you. So I just want to introduce you to the concept of what HPC is. I'm more of a developer than an infrastructure guy, so this is during this project I learned a lot about HPC. During no time did we do actually any development as such, but I'll just point you at the various different parts. And apologies about the format of the screen. I've actually got machines within machines, but if this is the standard HPC view, which is a cluster manager, it's really the traditional sort of Outlook view with tasks down the bottom and a view at the top. So there's really only three things that you need to use. And these are separated into two tools. One, I said, cluster manager has everything, and one has a job scheduler, which just has jobs. So I guess the most important thing is setting up how you're going to configure this. So first of all, what is the network setup? So head node, broker nodes, whether it's on the private network, what the sort of settings are. There's a concept of node templates. These are how instances are run by default, so how they are grouped. And the really other one that we're interested in is the sort of job template. When you run a job, what does it use in terms of resources? So there we've got maximum number of CPUs, but I can exclusively run it on, let's say, an Azure group or workstation nodes or my own grouping and create my own groups. From a node management point of view, I've got a whole bunch of Azure VMs, which I'll show in a moment. They're all listed. I can bring them online, offline. I can configure how they are used and whether or not I use workstations as well as servers, etc. I can look specifically at individual groups. I can even monitor how those are performing, what it's currently doing. So at the moment, this is the actual head node itself. It's not doing very much. And then finally, in terms of how the jobs run, there's a whole bunch of finished jobs that I've got here. If I look at one that I've ran earlier, it had 20 tasks. I can find what the details of that job were, where it was running, it was scheduled to run, what the individual resources it was using. So this one has about 30 or 40 different nodes that it's been running. I can look at what resources it used there, and it can tell me the Azure nodes and any other variables. So I can actually limit down the job. So basically, it's a combination of configuration, setting it all up, setting up the nodes, what you're going to run and how they're grouped, and then jobs, which are tasks that are there. So if I was to create a new job, just as an example, screen. Now there's a number of different types of jobs you can do in HPC. You can do parametric sweeps, so you can just run simple XEs, or you could offload to Excel, which we do in this case. I'll show you in a second. Or you can do SOA implementations, a whole range of things. But if I just call this a simple echo service, I edit the task. This is pretty easy. Hello world. I can set the parameters, save that job. I can set a whole bunch of tasks. I can also set activities that happen afterwards. So what happens on startup, what happens on cleanup. So creating jobs really easy. If you were creating a parametric sweep, which a lot of people using HPC do, you literally put a parameter in that says %1, %2, etc., and it substitutes that out and gets the values. Let me just submit that. So I submit that job. It then pops in as a job that I can run. There it is, very easy. Ran, echoed, come back. Now, okay. Okay, no worries. So I guess all I'm trying to show is that setting up jobs is something you can do yourself. But in terms of this particular solution, all of this was masked away. So there's no real programming, and there's very little interface you need to do because all of it's managed by the Excel workbook offloading. Let me show you the workbook quickly. So if I pull that up, just go across, make sure I minimize this. I've got a spreadsheet in the background. It literally has a couple of buttons, one to run the desktop, one to run the cluster. This is courtesy of numerics. I'll go into exactly what's in this sheet in a second. But if I've got the developer tab, I can look at what macro this is assigned to and find out what bit of code it's running at. I'll just jump into a little bit of code. I'm not going to walk into the specifics. But I said it uses HPC for Excel, so it offloads in a certain order certain activities. So it basically initializes, it partitions the work off to HPC, and then it does an execute. So those three different bits of code, effectively one sets up the session, one splits up the job into little chunks, and the execute actually copies values out of the market data and puts it into the spreadsheet for execution. And the spreadsheet allows me to vary the scenarios. The only other bit of code that's worth mentioning here is this area here. So there's actually 3 commands, and if any of you have done Azure, any of you guys done Azure? I looked at Azure, a couple. Azure has a bunch of commands. You normally use a portal site, but there's a bunch of commands. So underneath, it's got 3 commands. One that creates a pack, so it actually creates a zip file. I'll show you that in a second. One that uploads the image to the Azure instances, so it takes the spreadsheet, puts it up into Azure storage, and then one that does cluster run. And effectively, that cluster run runs the job scheduler I showed you a second ago. So it basically says start this job using this node group and all the parameters. So this is just a way of hiding it behind, but these are the 3 key parts and the macro framework that's used behind the scenes.
Cool. Thanks, Dave.
2.
All right, so can you hear me? Excellent, it works. So yeah, those macros that you saw on the screen, that was the sum total of the development type activities that are required in this solution. No C#, no additional VB besides the VB-like script that runs there. We're not going to blow up, we're all right?
Yep.
Okay, good. Excellent. So, yeah, out-of-the-box capabilities that were pulled together to address this particular solution, which once the hardware was stood up on premise, once the HPC architecture was defined and the software installed and built and tested, kind of worked pretty well, actually. So we were able to take the workload, the workbook, with numerics, essentially shift that off the PC onto this HPC grid and freed up the PC and able to run it pretty quick on the grid too. So this myth, desktop apps will lock up your PC and they'll make it grind to a halt. Well, you know, with HPC integration in the back, I reckon this myth is busted. Excellent, one laugh, great, hard crowd. Okay, cool. So the second myth that we're going to talk about, one that I mentioned is quite dear to my heart. That is that you know, banks can't use the public cloud because it's too insecure. I did mention that there is some truth to that, and I want to call that out right up the front. Customer information. So I'm a customer of a bank, like we all probably are. Is extremely important to banks. There's no way I can overstate that. It is extremely important to banks. It's looked after with maximum care and security. It doesn't leave the bank, it doesn't go offshore, it doesn't get outsourced. It is absolute Fort Knox material. As such, it doesn't belong on the public cloud. So that is the part of truth to the myth. There's a but here, and you know it, right? What about data that doesn't have customer-related information in it? Okay, so it doesn't have names, it doesn't have addresses, it doesn't have phone numbers, any of our personal information. What if that data is comprised mainly of publicly available information? information that can be found on financial websites like money.msn.com. What if the activity around this information, the processing requirements around this information, it requires huge compute capacity as well? Perhaps this could be a candidate to put on the cloud. So, when you look at the numerics data, and here's a quick snapshot, and I'm going to flick over to David in a minute, who will give us a quick run through. It's pretty meaningless, right? Dave, did you want to give us a quick run through of some of the data, and we'll go from there?
No worries. So just plug this across. Thank you. So just going back to the spreadsheet, just to show what's really in it. Like I said, there's only really 2 buttons. You know, as a developer, it's a little bit underwhelming. I wanted to get in and sort of program some bits and pieces, but really, like I showed before, there's only those 2 options. They run off exactly the same code. So if I was to run off the desktop here, I get exactly the same experience. My only other 2 variables that I've been using in my testing has been this number of polls or scenarios. This is that equivalent of that HPC macro you saw earlier, execute. It says partition. It splits this into 10 different activities. What this will do is ping it off to different cores. But if I actually look at the data and go through each individual thing, this is the sheet that Ward was talking about. There is the only other value I'm looking at is quality, which is on that yield. I'm looking at how many paths I can get through and the amount of memory that's using. So it's kind of CPU time, and I just vary that. But in terms of the actual data in each individual sheet, there's nothing in there that has any customer information at all. It's basically mathematical formulas and large lookup values. Like I say, apologies at the screen, but you get the idea that it's kind of just data. And when I actually run this, all it's doing when I press this desktop calculate here is copying a value from this top row, which is an amalgam of all the different sheets that I quickly went through there, copies it into each of the individual rows here, and as it's calculating, you see it says running. It'll take sort of 10 minutes, but you'll see it's starting to populate each one of these lines. So yeah, no customer data, just public information being crunched pretty intensively. I better kill my Excel.
Indeed. That's going to kill your desktop now.
Yeah.
Oh, thanks, Dave. Yeah,
sure.
So no custom data. Great. So no, absolutely, no bones about it. There's no customer information in use in this proof of concept. That is one of the absolute underpinning values that the principles that we proceeded on. So taking us back to our myth busting, right? So banks can't use the public cloud because it's too insecure. Well, with the right data and the appropriate amount of governance and diligence around that, I reckon this myth is busted. Okay, it was funny the first time-ish. The next myth, bursting to the cloud from HPC. So let me just stop there. So we solved the initial problem. Okay, Excel lock out the desktop. We put in HPC, offloaded the work onto HPC, desktop still running, numbers come back, results happen quick. Essentially, problem solved, yeah? If you go back to the objectives of this proof of concept, one of those was that it needed to support an ad hoc usage model and needed to be cost effective. As I mentioned, this task is not run every day. It's not run automatically. It's a user-initiated task that is run on demand and ad hoc, so maybe once a week kind of thing. So therefore, standing up an HPC framework, head node, compute nodes, broker nodes, plus all of the patching, the backup, all of the watering and feeding that would need to happen to keep that going. There's a cost attached to that, which would then skew the business value proposition out of the park. So we need to find another way, and that's where this HPC cloud bursting piece came in. Now, when we started the discussion with Microsoft and numerics, and the POC team was involved, we actually thought it'd be really easy. Oh yeah, you know, there's an HPC Azure integration piece. Just deploy the module, clickety clack, you're away. So it wasn't quite like that. So let's have a bit more of a look at that. What we did, right, to start this process off, the first thing is to build a VM, okay, a virtual machine, so Windows VHD files. This virtual machine is essentially going to have our HPC OS on it, it's going to have Excel on it, and it's going to have numerics on it. The idea being that we build these VMs, we set up our subscription, deploy the VMs out to Azure, spin them up, and that becomes the compute grid in our HPC. We're working through that process. Yes, we can build the VMs. Yes, we can set up a subscription. We got to the firewall, okay, and shifted down quite a bit. Bottom line is that the Azure HPC integration that we were using for this POC just didn't support a proxy, which, as a customer, you kind of think, well, hang on, HPC is going to be in a corporate environment, right? Like a bank or other company, or even in a university. It's probably going to be behind a firewall, right? And the cloud, well, that's going to be out there on the other side of the firewall. So fundamental design challenges there. And this middle section, the security challenges, consumed quite a lot, the lion's share of the time of this proof of concept. Having said that, we're going to go through that in a little bit more detail. Once we've got it working, we can numerics configure the script to use the HPC Azure commands like Dave was showing before to run the job out onto the cloud. And finally, the results that came back. This involved going back right to the beginning to the quantitative analyst that had the problem and said, look, we're running these numbers using this solution that we think is pretty cool, but are the numbers right? So that was part of it, right? Which is part of the journey. The architecture for this, at a high level, is like this. The scope of the POC that was built is extending on the initial piece that we looked at. The first sorry, that's my bad. Let me try that again. There we go. The first architecture that I showed before was really HPC with the on-premise equipment and the head node. We've augmented that with the Azure Management Console and the virtual piece out here, the cloud. This is the scope, okay? The point I'm trying to make here, the point I need to make is that the on-premise compute group we didn't need to do anything with that as part of this. But what we did need to do is leverage off the head node, which stays on-premise. So the head node essentially became, for want of a better term, our jump point out to the cloud. Mind you, jumping is a little bit of an overstatement because we've got to go through firewalls, and that was just not all that jumpy. So the head node stays on-premise. The workload still gets offloaded from the desktop to the head node, but from the head node, which is on-premise, out to the cloud and back in again to the Azure cloud. Now I'm going to flick up to a detailed slide, which I'll get David to run through because he's our Azure expert. Dave, are you able to give us the quick run through this architecture, please?
It's much the same as what Ward was talking about. I'm just going to go to a little bit more detail. So if you're not familiar with Azure, that's my screen with the ports. I will go back to the Prezo. Thanks. So yes, if you are configuring, you need a whole bunch of firewall ports open, and you need to open up to the Azure data center or whatever you're accessing. But in terms of how you operate this, I've split it into 3 different roles. I don't know if we can, there we go. These 3 different people. So yes, if you're running Azure, you can certainly run it all as one person, but I wouldn't recommend that. It's like, so if you haven't come across Azure before, it's pretty much exactly what you'd do on premise, but now you can perform all roles. I'd sort of recommend that you split these roles up. So the person who pays for the account probably isn't the best person to administer it. The person who runs the calculation or the person who deploys the services, again, all different roles. So effectively, we needed someone to set up an account. We've got a bunch of accounts that set up on the portal site on Azure. That's secured by a live ID. We've got somebody who can set up the individual storage accounts and play around with those, upload the VHD images, etc. So they go across into, so effectively a VM role is established, but that's established if you know Azure, it's got a template, and the VM role is kind of like the base image. What's unique about VM role at the minute, or rather standard about VM role at the minute, is that like the web and worker role, it complies to two main rules, which is it doesn't persist its data, and it also is load balanced. So but it's ideal for this environment because we bring the machines up, we bring them down, we use them for a fixed period of time. So uploading an image is kind of one-time activity. The Avanade team were differencing the disk, so you can actually change that and add individual values. Then you go and configure the HPC scheduler, like I showed you earlier, very simple. And then from there, at that point, the analyst comes in. They've just got that calculate button, nothing else, but a whole sequence of activities happens at this point. So effectively, we've got 4 or 5 different ports. Got some news about that later. This was the kind of problem. We had multiple proxy servers that were doing this kind of work. One was setting up the cluster itself, provisioning these nodes and coming back, and that was going via the head node. And then there's a broker service that runs as part of that head node that does those Excel macros that we did before. Those macros being execute this, partition this, bring it back. And then at the end of it, we have this node release task. Remember I mentioned the jobs. There's a kind of a task you can assign at the end. One of the things the bank's very keen about, of course, is making sure that the spreadsheet you've got, the VM role, everything you're using is removed at the end of it. Now, we've got guarantees in Windows Azure, but we want to be extra careful that any data that's not retained there. So, a bit more detail.
Brilliant. Awesome. Thanks, Dave. Now my turn. What I want to point out on this slide is this nasty stuff here. Right. Direct non-standard ports. Okay. Not sure if you can read it at the back, but there's the 7000 series and 5000 series ports. Okay, these are not your standard 443 and 80, which can be proxied. These are ports where the expectation is that HPC head node is going to talk directly to the cloud. Anyway, someone wasn't thinking. To make this, so clearly that's not going to work inside a bank because there's a number of firewalls, like dirty, big, great, secure firewalls between the bank and the rest of the world, which this has to cross through. So there's just no way it's going to go directly. So we had some challenges as to how to make that work. One of the challenges, one of the ways that we solved that was installing a bit of third-party software, which you may know. Proxy Cap. Anyone know this gem? Okay, yeah, at least one. So Proxy Cap is something that you really shouldn't be installing on a corporate network. It's a piece of software that is used to essentially redirect socket calls from your application. So where the application was trying to open port 7999 on a certain IP address, that call was intercepted and be able to be rerouted through to a SOCKS proxy. So suddenly SOCKS enabled application. Why it's not recommended, and please don't go back and install it on your corporate office because it's going to get you, the security guys will not be happy. We had security very, very closely involved in this, an active member of the proof of concept team that was driving and overseeing all the changes that we made. And just for this proof of concept, this was given the tick, and it was done in a closed-off, sheltered environment. Anyway, so with that in play, we're able to then upload, download our VMs, distribute workload out there. The architecture that was described up on the screen started to work. And work it did. When we ran jobs on the desktop, okay, now this is in minutes, and this is just one, okay? This is one point on that yield curve that I mentioned, okay? Where we've got 30 days, 60 days, 90 days, 12 months, 3 years, 5 years, okay? For each of those, this was the amount of time that was needed to do. What we did was then able to take that and run it in this many minutes, right, on Azure. And that was with provisioning 6 nodes. So, yay, happy days. This is looking pretty good. So being, really thinking in this kind of myth-busting mode, we thought, well, if 6 nodes works that well, what happens when we throw a lot more at it? How fast is it going to run? How is this going to scale? So we did a whole bunch of testing and applied additional nodes to the equation. One of the interesting points which we're still working through now is the scaling piece. Although we suddenly get a drastic drop in terms of the runtime, as we apply more nodes, so just remember, we make the compute grid bigger. This is having more ants to do the piece of work. As we throw more nodes into this compute group, we find that when we hit about 20 or 30, it's running really well. But when we applied more, when we threw more nodes into that compute group, it started to actually slow down a bit, which was odd. Not quite sure why that is. Remember, we're running beta VM role software, so it's probably something to do with that. But it's still being worked through as part of Numeric's and Microsoft's engagement. Having said that, though, don't you think that's a reasonably good result? All right, going from over 300 minutes down to around 15. I do. I thought it was pretty good. That's half of the equation, getting it done quicker. The other half is then taking those numbers back to the quantitative analyst and saying, but are they correct? Right? Which is something that can take a little while to do. So, with HPC, bursting out on Azure, we found that simulations run much, much faster. If we think back to the goals of the proof of concept, that was one, that we had to provide faster and more calculations. We're still working through some of the scaling aspects. I expect that that's part of the journey that the vendors will be on to figure that out. But even so, right, even with 6 nodes, it was significantly better. So on that basis, we said that this is a pretty successful outcome. So, therefore, burst into the cloud, okay, with HPC and Azure. Is it cheap, quick and easy? No, this myth is busted. How are we going so far? So, myth number 4, and this is our final myth, that all clouds are created equal. So, how to say that another way? They're all the same, aren't they? It's just another cloud. So, when we got on this journey, there was a number of different questions being thrown up about which cloud to use, why this one, why that one, the why Azure question. Really, the question is, can't all of the clouds do the same thing for us? Can't we burst to the cloud with HPC to solve this problem with all the other clouds? Well, that's the myth. So, when you look at it, having a Windows or a Microsoft solution from end to end, so Windows technologies-based application on the desktop, plugging into Windows, Microsoft Excel, plugging into Microsoft HPC, plugging into Microsoft Azure. As we found out through this proof of concept, when things didn't go to plan, there was just one throat to choke. There wasn't this case of talking to multiple vendors and having to have a huge escalation process and all those complexities that we do. One person on the hook for it. That made it a lot easier. It simplified the process considerably. There's a single API and toolset across across the platform, and integrated end-to-end management capabilities. So on that, I want to demo that. We saw, and I'm going to throw to David in just a second, we saw HPC managing those compute nodes that were on-premise and being able to check the workloads and all the rest. Well, guess what? When those compute nodes are actually sitting out in the cloud, it's the same tool set. There's another Azure console that sits side by side, but it's not as though there's a completely different way of managing them, and that's a key point. So who wants to have a look at that, how that all works, managing those nodes through HPC on the cloud, yeah? So Dave, did you want to give us a run through on that?
Flip us across. Thank you. So I guess what we wanted to say is with all of this that it's all about configuration. Once you have a workload to run, it's about configuring the steps and basically understanding that. I've got a bunch of guidance online, but I'm going to walk through the main parts to show you how you get from having a basic Azure subscription through to running a job. And if you want to see more, come and see us afterwards and we'll walk you through this. So I'll just show you my account. I'll log on to the Azure portal, which is windowsazure.com. Actually, I've already signed in before, so it's pulling up the details. Again, this sort of Outlook kind of view with a bunch of activities down the side. Might I say that at this point, that Azure is a platform. It's almost like a brand like System Center, so there's a whole raft of things Azure does over and above just being provisioning VM instances. So the portal site allows you to manage those. What I'm interested in is a bunch of options I talked about before around storage, around the hosted services and so on. So if I just click hosted services, my options change around what I can do. I pull up the ones that I'm running. I have two accounts here. One I've kindly borrowed from Avanade, thank you, and one of my own. And the Avanade one I kind of set up myself really because, and I'll show you the differences. On my account, I've got a bunch of sort of test apps I'm using, and I've got 20 cores and a bunch of hosted services. These are like applications I can use. And I've got 5 storage accounts if I want to play around with those and name them. So I can arrange applications in a way that's kind of fun. The Avanade one's a little bit more serious. I've got 484 cores to allocate. At the moment I'm using 202. I shall show you how I've done that. It is arranged thus. So there's effectively a hosted service, which is the container for it. There's a bunch of management certificates that allow it to run, and remote desktop too. There is a proxy. Let me just bring that across a little bit. So there's a couple of proxies that are built in. So when you deploy this, it says, I need some proxies to get there. So it's kind of an extra security measure. And then it has these VM images. I've actually made 100 of them, just all of the medium size. And they're all the way down. Two key parts of this is that you need a management certificate. So this is the sort of thing an IIS or get from your security provider to publish that. Otherwise, you can't. The HPC cluster manager or job scheduler won't be able to talk to Azure. So you publish your certificate up there. The other thing is that there's this storage account. So in this case, there's a number of different types that we're using. If you're familiar with Azure, you can get this by programming, or you can use a bunch of tools. I've just pulled up one before that's got these packages, and inside there, remember it's an interest delta report. So that zip file is one that's literally been packaged together using that HPC pack command you saw earlier in the Excel spreadsheet. So each of these have just been uploading there. In fact, this contains the VM image itself. So if I go back to the portal site, down here, I've got the actual VHT that I've uploaded previously. So everything can be managed there. I can absolutely destroy it from here. Again, the division of roles and responsibilities is important. But you get the general concept. Just switch to my VM image, back across here. Now, if I was to set this up from scratch, I would actually create a node template to start with. So I'll go to my configuration, see, and just literally right-click and do new. It'll give me a node template. I say I want a Windows Azure one, thank you very much. Next, call it what I want, you know. I've created one already. I won't go through this process, but just to give you an idea, I can paste in my subscription ID that came from that portal site just to make sure I'm not getting you blindsided. I go inside here, go to this account, and down here is that subscription ID. So you just copy it out. I need that management certificate on my HPC server as well. So when I swap back, you'll see it's asking me for that subscription ID and the management certificate that has been set up already and uploaded to the portal site. Those two allow me to go in and it pulls up the service information, away we go. So I've built one of those already. In fact, I've built two. So this one here has got no nodes in it. This one's got 100 in it. And literally, it tells me details. In fact, it's got a whole bunch of other options, but I won't go into here around connecting to this exclusively. So you can create a virtual private network with Windows Azure Connect. So that means that only those machines are visible to you on your network. We didn't do this in the proof of concept, but it's slated, I think, for later on as the operational side of things. We did put in remote desktop, which I'll show you in a second. So there's a bunch of things you can do to control the actual the nodes that you've provisioned. When I go to the node management side of things, really simple again. I've created one here that's blank, that one with 0 in it. I can literally add nodes. At this point, I can say, rather than add on-premises nodes, I'll add some Windows Azure ones. Next, at this point, I can just say, well, you know, I want 50. Would that add up? How many have I got left? 200? 250 times 4? I'll put 40 just to be safe. And I'll use large ones. Now, these sizes are predefined. In Windows Azure, we have extra small, which is a single core limited CPU that runs about 4 cents. So this is kind of a cost versus value statement. If you run up to medium size, it's an increment larger. I think we worked out. You don't mind me mentioning cost to you, Ward? Well, this is something you can work out using our pricing calculator. You chuck it in. If you're using an hour of this, we worked out roughly for about 80 to 100 cores. It's somewhere in the region of $4 or $5 an hour to run. So pretty small. Also gives you the option of saying, well, do you want the calculation quicker? What does it cost? $5. Yeah, fine. Got to go. Also means that retrospectively, you want to switch this stuff off. You don't want it running all the time because it's costing you as you run. So you can schedule that with a job scheduler. Like I say, I'm just going to pick 40 of these, provision them. Away we go. Almost immediately, you'll see those nodes. He says confidently. There we go. But that actually does nothing. It basically just adds it to a database within HPC. If I select all of these, at that point there's 2 steps. And the reason why I've done it in this separate node template is because it takes a bit of time. I'm not sure how long it takes you to provision a server. I don't do that being a developer, but my experience of that is it's weeks. In Azure, it's 10 minutes, but in terms of a demo, it's pretty dull watching this spin around for 10 minutes. There's only 2 activities here. You start them. I'll begin those 40 nodes. It will go into Azure and say, right, I want to create these. At this point, it's creating that proxy group. I've already got one, so that's fine. It's then going to take those 40 nodes, bring them up stage by stage. So it's taking that VHD image I saw earlier, bringing it up, and then allocating a bunch of actual physical servers in there. Once they're all provisioned, it'll come online, and then I can start them. So I'll just go back to the portal, and you'll be able to see these, he says. So let's go down, let's see what I've got. I should see a whole bunch of new ones, if all going well. Here's my service. Well, I'll come back to this in a minute, but usually within about 30 seconds, all of these pop up. So I've got my proxy already. There should be another 40 or so popping up in a second. Let me come back to that. So they're all busy doing the thing. In fact, until it turns transitioning, I don't think it actually creates the instance. With those running, I can actually select what nodes I want to run. In fact, the one that I'm using is this T4 case here. I said I got 100. I've actually taken most of them offline because if you remember in the partitioning here of the spreadsheet, I've got this finished in about 10 minutes. I've got 10 of them. What that will do is allocate 10 cores. I've actually allocated 100. And it's not even 100, it's actually 100 times by 2 because they're medium-sized instances. So that's 200 cores. The 200 you saw earlier, 200 plus 2, 202. Obviously, that's overkill for this scenario, so I've reduced it. I can bring those all back online as well. So let me just do that. So there we go. Bring them back online. So select all of these. bring online. And they're immediately available for that calculation. I can actually separate my calculation and say, I want to use these nodes for this one, this template for this one, this time for this one, completely controllable. They're all beginning. So if I go to my spreadsheet, literally by pressing calculate, it will begin this activity. So all going according to plan. Come across here, go to my cluster. Now, what I'm interested in is how the nodes are running. So I'll select all of them and get a heat map. And then slowly but surely, all of these, they're all at 0 at the minute because they're all allocated very little tasks because they're all busy. They're all underutilized because I've got more capacity than I'm actually running at it. But what's interesting about it is, and this kind of never ceases to surprise me when I look at it, just pick any random one. Let's pick one here. And I remote desktop to it. And it surprises me because I don't know what I was expecting before, but when you go to Azure, it's a Windows server. It's just, every time I go to it, I find windows that I've used before and they're open and stuff, and I'm like, wow. But it's just the Windows server. It's kind of, the first couple of times you're like, wow, and the next couple of times you're like, well, what did you sort of expect? So literally, what this gives me the ability to do when I was testing is go inside here, pull up the instance and see what was exactly running the machine. I can actually go in and do anything I can do in Windows Server, I can do in Windows Azure. So I can go in there and muck around with certificates, I can install packages, I can do all sorts of things. Bear in mind, of course, those two key facts. One is that the Azure instance is stateless. So persisting things won't happen for you. It will happen between sessions, but the chances are your IP may be moved, you may get a security attack, you may pull the service down. All those things basically mean that you can't guarantee that the data that's on that instance is still going to be there, and it's load balanced, so it's switched around. So just trying to prove to you this is actually a machine. So the cell calculation's already come back. That was, instead of the 300 seconds, is about 30. If I just pull up, let's just do Task Manager. So I'm showing you it's actually a real machine rather than just, and there we go, and I can see tasks, and if it were running, it's finished quicker than I thought, I'd find the Excel instance and what it's running inside there. So quick run through. If you want to see more, come and see me afterwards and I'll show you how all this works under the covers.
Cool. Thanks, Dave. One of the key points for me as an architect trying to solve business problems is that the ability to take a computationally large problem, break that down into activities that can run onto HPC, and then clickety-clack, set that up by provisioning a bunch of nodes in the cloud in minutes. And personally, I think minutes is too slow, but I'll leave you guys to be the judge. I would like it to happen straight away. But provision those nodes in the cloud, run the job, get the results back, and then essentially scrub the cloud so that your images aren't out there, your data's not out there, your application's not out there, it's gonski. To do that, just having the head node installed on the local the on-premise, quite a neat solution for those kinds of jobs. Once again, all clouds are created equal. Well, all of the stuff that you just saw there, the integration with HPC, back to Excel, back to numerics, it's much simpler to do and straight out of the box on Azure. So my view is that myth is busted. So, big question is what happens next? Well, this proof of concept is really to prove a single concept that we could solve this user's problem. And to do that, we went on a journey, and through the use of Microsoft Azure and HPC, we were able to get a reasonable result. What needs to happen beyond that proof of concept out in vendor land, if you will, is quite a bit of re-architecting and work. One thing is around that firewall and proxy support. That the HPC Azure integration between the head node and the cloud, it needs to fully integrate and understand firewalls. Right? That caused us so much pain. On top of that, the VM role, I mentioned beta, clearly that's got to get into production release before anyone can start thinking about using it in that sense. On the numeric side, remember it's a desktop application, so putting that onto the cloud, there's, it's the words you hear often. It's a paradigm shift. Licensing, deploying, managing, how that all works so that you can harness the elasticity of the cloud using the application. There's some architectural work that needs to happen there, including exploring the use of other cloud services like App Fabric, where we can have potentially different VMs sharing information between each other through the fabric. Just as some of those things. And as Dave mentioned, there's also Azure Connect as well, which gives a completely different view, essentially like a VPN on the cloud. But I mean, for more information on that, talk to David about it. That's just my non-Microsoft view of it. From the customer perspective, so there's once again it's a mindset shift. There's lots of operational and governance procedures that would need to be put in place. One of the things I'll point out is around the infrastructure and operational guidelines. As Dave pointed out, as soon as you spin these images up in the cloud, the meter starts running. So most of the development teams that I've worked with, the box is pretty much running the whole time. Yep. Whether it's actually being used or not. The mindset here is essentially turn on, do what you need to do, turn it off. Otherwise, the meter keeps running. Even though it sounds pretty cheap, it's going to add up after a while. So, quickly, today we had a quick look at Monte Carlo, very CPU intensive, used in financial institutions to go and calculate price. Can smash desktops. How do we fix that? We went on a journey. We looked out to HPC integrating with applications and Excel. Went on a myth busting exercise as well, that around the desktop grinding to a halt, that the cloud can't be used, and that connecting to the cloud is quick and easy. Also, finally, that all public clouds are the same. As we've seen with the demos that Dave have done, these myths have well and truly been busted as a part of this proof of concept. So, proof of concept is now completed. The vendors are still working through a few other issues around the scaling and these sorts of things. So, I'd pretty much like to wrap up the session there and open the floor for some questions. We have one last bit of late mail. So Dave, lay it on us.
Yeah. Well, there was a few issues with this proof of concept. Like we mentioned, we want to be open with you around what sort of challenge you might expect if you do it. It is all about configuration. None of it's about development. I think I've tried to emphasize that. But on the configuration side, what's coming up? So we started this project, I think we were in like a beta, one of the bursting capability, this ability to offload the whole workbook. What's happening in SP3 for November is that, thankfully, they've taken our feedback on board, the product team, and port 80 and 443 is standard throughout. So basically, all those port issues go away in November. So if you were going to do this, good news. Second bit of news is that you may have been reading, if you check up with this sort of thing, or you're interested in MapReduce or Hadoop or all those algorithms, we've been doing a bit of work in Microsoft Research called HPC or linked to HPC. That's based off of ways of improving MapReduce algorithms. We figure that's about between 10 and 20%, I believe, better than Hadoop. A little bit more programming involved, but that allows your developers to get more out of the HPC environment. And the last thing is, this is a hybrid environment, so you can use your own resources and Azure or not, and all the different combinations they're in. What we are adding in November is the ability to have that job scheduler in the cloud as well, so in the Azure data center. So effectively what you can do is, rather than just provision nodes like you saw me do, in fact, I'm going to switch back and I'll show you just to prove I was, is it there? I'll switch back. Thank you. So there's the The large VMs instance, by the way, is actually now provisioned. If you thought this wasn't working, it's actually now up there. So I've now got those 2 services. I guess in addition to those sort of tools, now you can take the job scheduler, give someone that role, and it's wholly running in the cloud, which is another extension of that hybrid model. So a whole bunch of new things coming in Service Pack 3 in November.
Fantastic. Late mail. Okay, so thank you, Dave. That's awesome. Questions from the floor? Promise you some time. Yep, so down the front.
Good question.
Okay, good question. So the question was, how do we handle the licensing issues for Excel when we had so many VMs running? Good question. That sounds like a Microsoft question. So I'm going to pass that over to Dave.
Short answer with difficulty. No, it was a sticky one, and Adam at the back Barker was involved in this. So I guess we're still working on that. We haven't got the confirmation, but it looks promising that, of course, this is a key scenario which we'd be running. But would you believe Excel's not, as you mentioned, is not cloud ready at the moment? It's cloud, technically possible, but in terms of licensing, an interesting question. So I suspect that'll be resolved. Is that a fair comment, Adam? Would you say? Okay, talk to Adam.
That's a good point. We're here all week and open for questions later as well. So, are you okay with that? Yeah. Answered. Thank you. So, second question. Yeah. Same question. All right. Yes. 2 with 1 blow. Well done.
Sure.
Sir.
The data validation. Did you actually bust that thing? So it was actually validated, the data was actually correct. Irrespective of whether it was on the desktop or.
Okay. So the question that I'm hearing is were the results that were produced when we took it back to the quantitative analyst? Did he give those the tick?
Yeah.
So good question. Answers yes. He didn't find any issues with it. So. Good question. So was it a Friday afternoon, quick haphazard discussion? So absolutely not. So our quantitative analysts generally are extremely thorough. I think Rain Man detailed, like life depends on it type detail. So there is no haphazard, but it's a good point. Yep. Okay,
and you've been running this before on premise, so
on premise.
So it's not all this is kind of like runs here. Let's run it over here. Same result. Fantastic.
So yep, please.
You showed us some performance statistics. We went from the desktop to Azure, really improved there. How did that compare to your on-premise to your on-premise?
It's another good question too. So the question is, how did the on-premise HPC go compared to the rest of it? So I'll tell you what, right? We've been told we're out of time, but I want to answer your question. So you want to come and grab me after and we can have a chat over a coffee? Because this is a good discussion. And that goes for any. If anyone's interested in having a chat to David and myself or the Numerics or Avanade guys that are here today, come and grab us. And because I know everyone likes to have a chat. I apologise for cutting off, but really let's catch up straight after this. So look, thank you.